Hi Kayla, I wanted to give my response to your video. I wanted to preface by saying that I do agree with, to an extent, with what you're saying. You bring up that there are two main things that are involved in this release of oxygen to the tissues, being pH and CO2. And by that logic, my thoughts would be that if we have the same pH in the tissues compared to, let's say, in the lungs, then we should relatively think that there shouldn't be much of a release because of that pH being close to where the pH of the lungs are. However, at the same time, you do mention a lot how CO2 plays an important role in that release. So the main thing here being carbamate in how it can bind to those terminal amino groups, create that negative charge that makes the hemoglobin structure of the T-state hemoglobin more stable, that is prone to more release of oxygen. Whereas on the topic of pH, with CO2 being able to convert into carbonic acid and releasing protons, if we're saying that the pH is the same, then I don't think this will have much effect on the release of oxygen, but this will still, the carbamate group formation will still have a slight effect on that release. So my thoughts being that we would still see more of a release of oxygen compared to in the lungs, but not as great as if the pH was lower. And I also did want to point out a slight little variation in that you didn't really mention too much about 2,3-BPG. I think this would also enhance this loss that we get because of that similar pH, but the 2,3-PPG would still have an effect of releasing oxygen by stabilizing that T state with its negative charges that can bind to these different portions of the hemoglobin globin chains.